So in 7.4, we will be solving polynomial equations in factored form. Now let's look and see what this means by factored form. In standard form, right? So here's standard form. We have this polynomial x squared plus 5x. Well, now in factored form, you'll notice each one of these terms has an x value in it. So we could think about, we took that x from both of them and we brought it out here in front, and then what are we left with? Well, over here this first one, there was x squared, meaning we had x times x. So when you multiply this out, x times x gives us x squared back. So we took one of those x's. And then if you distributed this this x towards 5, you'll notice that we get our 5x back. Okay? Now, this one, x squared plus 3x minus 10, that trinomial in factored form gives us x plus 5 times x minus 2. And I'll explain that one later, how we factored that. Okay, so I just wanted to introduce what standard form means, what factored form means. That's all. That's the thing that I wanted to address here. All right, so let's start looking at some examples. So example 1, we want to solve the equation. All right, solve the equation. I'm given 3x is equal, 3x times x minus 6 equals 0. Now I think you're going to want to start multiplying. All right, fight that urge. We don't want to do that. We do not want to multiply. All right, no distributing, no FOIL, no double distributing. It already is factored and it equals 0. That's what we want. So in order to solve this thing, I'm going to take each factored form and I'm going to set it equal to 0. So I'm going to take that 3x and force it to equal 0. And then I'm going to take this factored form right there, and I'm also going to make that one equal 0. They call this thing the zero product property. Okay, zero product property. And now you're going to solve each one of these. You're going to solve each one of these for x. Alright? Just like you'd have done way back. So 3x equals 0. That means 3 times x equals 0. How do we undo it? We divide both sides by 3. X divided by, 3x divided by 3. The 3's cancel. I'm left with 1x. 0 divided by 3 just gives me 0. In this case, x minus 6. How do we undo subtraction? We have to add 6 to both sides. So then I'm left with x is equal to positive 6. Now there's a whole bunch of names for these things. There are so many different names for them. These things are called solutions, roots, and then later on you're going to see why they're called x-intercepts or even zeros. Alright, later on, once we start graphing, these will make sense. We're not going to be graphing quite yet. Alright, so I want you to try one. X plus 5 times x minus 4 equals 0. You seen what I did above? You seen what I did above? Hit pause, you try it. You're solving for x. Alright, let's start going through it. Set each one, x plus 5 equals 0, x minus 4 equals 0. Subtract 5 from both sides, because how do I undo something that's positive? By subtracting. So I'm going to subtract 5 from both sides. X, those cancel out, is equal to 0 minus 5, negative 5. And I'm going to add 4 to both sides. So x equals, those cancel, positive 4. So here are my roots. My roots are x equals negative 5 and x equals 4. Alright? I hope that's straightforward enough. What happens if they start getting a little bit uglier? Alright, what happens when they get a little bit uglier? So 4x plus 5 times 4x minus 5. Alright, give it a try. Hit pause. Well, you guessed it. We force each one to equal 0. Alright, so I'm just rewriting it in this zero product property. Now subtract 5. You've done this before. You should have no issues. Alright, those cancel. Divide both sides by 4. X is equal to negative 5 over 4. Now, since I'm not doing anything with it, you guys know, just leave it as an improper fraction. Alright, if I have to do something with it later, then we'll think about changing it to a mixed number. But right now, just leave it as an improper fraction. Don't do extra work. Alright, we're adding 5 to both sides because we have that negative. 4x is equal to positive 5. Divide both sides by 4. X is equal to positive 5 over 4. So my roots are x equals negative 5 over 4 and x equals 5 over 4. A few more, just in case you ever see a problem like this. Now think about what we were talking about when we said when something is squared. What does that mean again? Well, I'm hoping you remember. That just means we write it out 2 times. Okay, we're writing it out 2 times. Now, put it in that zero product property. So x plus 6 equals 0, x plus 6 equals 0. And you notice they're exactly the same. Alright, so we're going to subtract 6 from both sides. You know what to do. I'm not trying to insult anybody's intelligence. You know what to do. But in this case, both of those answers are exactly the same. So don't write it out twice. What are my roots? My roots are x equals negative 6. Because it's the same exact answer. So you write it down one time. X equals negative 6. Now let me challenge you. See what you can do with this one. X plus 5 times x minus 2 times 14x minus 7 equals 0. Alright, what do? Hit pause, try it. Alright, so I'm hoping I didn't confuse anybody. I'm hoping you guys all had success. You guessed it. Set each factored form equal to 0. Right? We want that factored, we want that zero product property. Alright, so set each one of those equal to 0. And now simply solve for x just like you've been doing. Subtract 5. So x equals negative 5. Add 2. x equals positive 2. Add 7. 14x equals 7. Divide by 14. X equals 1/2. How many of you guys did I catch putting 2? Remember, the smaller number is on top, so it's going to be a fraction. Don't make that goofy mistake. Alright, the smaller number is on top, it's going to be a fraction. So there are the roots. In this case, this one has 3 roots. I wonder why. I wonder why this thing has 3 roots. Just curious. I hope that's a little hint why that thing would have 3 roots. Alright, so now let's look at this graph. Alright, don't worry, you're not graphing anything yet. But y equals x plus 4 times x minus 3. I want you paying close attention. Alright, so like I was saying, I want you paying very close attention to where does this graph cross the x-axis? This right here is the x-axis. I want you paying close attention to where it's crossing the x-axis. So do you agree on the x-axis y equals 0? Alright, I hope you agree with me. So if we take this y equals x plus 4 times x minus 3, if I'm worried about where it's crossing the x-axis, well then I guess I should take y and force it to equal 0. Alright, so I have 0 is equal to x plus 4 times x minus 3. Again, set each one of them equal, each one of these factored forms. Alright, set each one of those factored forms equal to 0. So x plus 4 equals 0, x minus 3 equals 0. I know you guys are good at this already, so x equals negative 4, add 3, x equals positive 3. Does this, what do you guys think here? X equals negative 4. Does that point look like it's at negative 4? What about this point? X equals 3. Is that 3 on the x-axis? If you're still not sure, there's 1, there's 2, there's 3. Negative 1, negative 2, negative 3, negative 4. Alright? That's the reason why we solve looking for roots. Alright? Remember way back up here I said that we also call these things the x-intercept and the zeros. Alright? So why is it called the x-intercept? Well, these are x-intercepts because in this graph it's where it crosses the x-axis. Why is it called zeros? Well, because y is equal to 0. That's the reason why they're called zeros. Alright, one more. You give it a try. So here's a graph. Again, pay close attention when you're solving. Pay close attention. Alright? Give it a try. I'll wait. Y is equal to negative x times x plus 6. Again, on the x-axis, y equals 0. Alright, so let's force this bad boy to equal 0. Negative x times x plus 6. And again, no change. Set each factored piece equal to 0. So negative x equals 0. Set each factored piece equal to 0. x plus 6 equals 0. Well, you guys know by now there's that 1 sitting there. People in math are lazy. So what am I going to divide by? I'm dividing by both sides by -1. Well, x equals 0. Yes, x equals 0. And then subtract 6 from both sides. X equals -6. X equals -6. Right? So when you're looking for these zeros, these solutions, these roots, whatever you want to call them, you're going to hear them by all those different names. So get used to them. Alright, get used to hearing all these names. Roots, zeros, x-intercepts. What was the last one? And I know somebody's already yelling at me here. Solutions. Sorry. And solutions. Alright, so get used to it.